All right, in this video, we'll cover the first half of the Unit 9 test review. Problem number 1, or it says Part 1, volume and surface area of 3D figures. Problem number 1, a classroom globe has a diameter of 16. Well, that means that the radius is 8 inches. What is the approximate surface area and volume? All right, so the surface area formula for a sphere is 4 pi r squared. And the volume formula for a sphere is 4/3 pi r cubed. All right, so if I want to find the surface area, 4 pi times the radius squared, and let me grab my calculator. And if I plug that in, and I'll leave it in terms of pi, so I'm just multiplying 4 times 8 squared. This is going to give me 256 pi, and this would be inches squared. If I were to go ahead and work it out with pi, that would be approximately 804.25 inches squared. The volume would be 4/3 pi r cubed. And in terms of pi, I would just multiply 4/3 times 8 cubed, and that would give me approximately 682.67, and this is going to be inches cubed. If I went ahead and worked out the pi, that would give me approximately 2,144.66 inches cubed. For problem number 2, we have a cone, and it wants the surface area. So surface area of a cone is going to be pi RL plus pi r squared. So this is the area, the lateral surface area, and then this is the area of the base. And then that's all it wants for this one. So let's go ahead and plug in our values. So surface area is equal to pi times the radius, which is 4. The slant height, that's your L. That would be 16, plus pi times the radius squared. All right, and I'll work it out both ways. So just in case your answer is in terms of pi, it would be 64 pi plus 16 pi. And if we add those together, that would give you 80 pi. So in terms of pi, that would be meters squared. Or if I wanted to go ahead and work out the pi, approximately 251.33 meters squared. In problem number 3, find the surface area and volume of the pyramid. Okay, so the surface area is 1/2 the perimeter of the base times the slant height plus the area of the base, and the area of the base in this case is a square, and then it also wants the volume. So volume is 1/3 base times height. All right, so let's plug it in. So surface area is 1/2. The perimeter of the base, this P would be 40. The slant height is given as 13. That's this guy. Plus the area of the base. The area of the base is just 10 times 10, which is 100. All right, I don't have any pi's or anything, so I'm just going to go ahead and put this whole thing in the calculator. And that gives me 360, and this is centimeters squared. Remember, area is always units squared. Now the volume is 1/3 area of the base, which we've already figured out is 100, times the vertical height. So the vertical height in this case is going to be 12. And so this is times 12. So 1/3 times 100 times 12, this is going to give me 400 centimeters squared. Cubed, sorry about that, volume. Problem number 4, for small paving jobs, a contractor uses a roller pushed by a coworker. What is the area of the pavement with which the surface of the roller will come into contact in one complete rotation? And so then it gives you a little hint. Find the lateral area of the cylinder. Okay, so lateral area of a cylinder is going to be 2 pi RH, where R is the radius and H is the height of the cylinder. And so for this one, the lateral area is 2 pi. The radius is given as, this is an 8 right there. It's kind of hard to see. And then the length, or I'm sorry, the height of it is 30. All right, so let's go ahead and put that in our calculator. In terms of pi, that just means you don't work out the pi. It is 480 pi, and this is area, so inches squared. And if I do multiply it by the pi, it's going to be approximately 1,507.96 inches squared. So either of these answers. Problem number 5, find the total surface area of the regular hexagonal pyramid below. So we want to find total surface area. And it says, remember, you need the apothem. Okay, so surface area, this is our formula, 1/2 perimeter of the base times the slant height plus the area of the base. This area of the base, well, that's the area of a polygon, regular polygon, and so this is 1/2 apothem times perimeter. Okay, so we have a bunch that we need to work out. First thing, let's start with something easy. Let's see, the perimeter. If each side is 20, and I have 6 sides, the perimeter is 6 times 20, which is 120. The apothem, let's go ahead and work on that next. So in a hexagon, we can find one of these angles. So let's see, I'm looking at this hexagon here. If I want to find one angle, that's going to be 180 times n minus 2 divided by n, where n is the number of sides. So it's 180 times 6 minus 2 over 6. So 180, let me multiply this out, and that gives me 120. So each of these angles is 120. And so let's go ahead and divide one of those angles in half. Okay, so I'm going to draw my triangle. This is just like we did back in Unit 7. Okay, if each of these angles is 120, and I cut it in half, on my triangle, I'm going to have a 60-degree angle. So this is a 30, 60, 90. Now, it's going to be half of the length of one side, so this is going to be 10. So this is my 30, 60, 90 triangle. X, x root 3, and 2x. Across from the 30 is 10. So my apothem, which is across from the 60, this is my A, is going to be 10 roots 3. Okay, so now we found the A. The A is equal to 10 roots 3. All right, so now I'm going to go ahead and start plugging in some values. So surface area is 1/2. The perimeter we said was 120. The slant height, I don't think we have the slant height yet. Let me think. No, we have, let's go ahead and draw, because what we need to do, let me go ahead and highlight this in another color. We have a right triangle right here. So I'm going to draw that right triangle. And it's telling us the vertical height is 22. And we just found out that the apothem, which is the same as this piece right here, this is 10 roots 3. So we need to find this value. A squared plus b squared is equal to c squared. So let me go ahead and substitute in. So we have 22 squared plus 10 roots 3 squared is equal to c squared. And let's solve for c. I'm going to go ahead and just work this all on my calculator. And take the square root. And it turns out that the C is equal to 28. That is your slant height. That's the L. All right, so now I'm going to make a substitution there. So that's times 28 plus the area of the base, which is 1/2 the apothem, times the perimeter of the base, Okay, that's what we're putting into our calculator. So 1/2 times the perimeter of the base times the slant height plus 1/2 times the apothem times the perimeter of the base. Okay, grand total, my surface area is approximately 2,719.23, and this is centimeters squared. Okay, on problem number 6, find the volume. Volume of a cylinder is just base times height, and we can see that the area of the base is a circle, so this is pi r squared times height. All right, so volume, pi, the radius, if the diameter is 15, the radius is half of that, so it's 7.5. And then the height of our figure is 12. Okay, I'm going to stick this into my calculator, and it's going to give me 675 pi, and that's yards cubed. And if I go ahead and work out the pi, that is going to be approximately 2,120.58 yards cubed. I'm going to just double check my math there. Pi times r squared times the height, r squared times the height, 675 times pi, and 2,000, yeah. All right, next one, we have a triangular prism. Okay, so the base on this prism is this guy. Remember, you always have two bases, two congruent bases. So these are the bases. And then the lateral sides are rectangles. Anyway, the volume formula is just going to be base times height. And since our base is a triangle, the area of the base is 1/2 base times height times the height of the figure. And so in this case, my volume is 1/2 the area of the base. So the base, I'm going to go ahead and call this my base and this my height. So this is going to be 8 times 6. That'll give me the area of the triangle times the height of the prism. The height of the prism is this guy, so times 2. So 1/2 times 8 times 6 times 2. In the calculator, that gives me 48 meters cubed. All right, in part 2, composite shapes of 3D figures. The box shown is a candy container with a square base and a pyramidal top. What is the total surface area? Okay, so let's figure this out. Okay, so we have the lateral surface area, or the lateral area of the pyramid. Okay, and so those are going to be all of the faces of the pyramid. Plus we have the lateral of the cube, the lateral surface area of the cube. Okay. And so, oh, and then we also have the base of the cube, because we're talking about all the surfaces that are shown. So again, the lateral area of the pyramid, those are the sides of the pyramid. So we got these sides, all of these triangles. That is the lateral area of the pyramid. And then we have the lateral area of the cube, and that would be all of these faces. We have the 4 faces. And then plus we have the base of the cube. Now we can't really see that, but that would be underneath. So maybe we can, like 3-dimensionally, you can kind of see where that would be underneath. All right, so we need to find the areas of each of these. Okay, and so here's our formula. It's going to be 1/2 the perimeter times the slant height plus the perimeter times the height of the cube plus the area of the cube, area of the base, which is just length times width. All right, so we're going to go ahead and figure out all of these. Now the perimeter, we just need to add this up. The perimeter, each side is 12, so it's going to be 12 times 4, and so that's 48. And we do need to figure out, let's see, we know the slant height. The slant height is 19. We do need to figure out, what else do we need to figure out? Oh, the height. We need to figure out this guy. Okay, and so what we're going to have to do is we're going to have to draw in a triangle. See, we need to figure out what this vertical height is right in here. And so this little triangle that I'm trying to draw in there, I'm going to draw on the side right here. And maybe we can understand it. So the slanted is 19. And we know that this little piece right here is going to match up to this little piece right here, which is half of the whole side. So this is 6. And we just need to find this. This is my height. All right, so a little Pythagorean theorem on the side. 6 squared plus 8 squared is equal to 19 squared. And 19 squared minus 6 squared. And I take the square root of that. And that's about 18. So I'm going to say this is approximately 18.02. So the height is approximately 18.02 if we work out Pythagorean theorem. Okay, so 1/2 the perimeter, which is 48, times the slant height, which is 19, plus 48 times the vertical height, which is about 18.02, plus 12 times 12. All right, so now let's plug this all in your calculator. 1/2 times 48 times 19 plus 48 times 18.02 plus 12 times 12. And that's going to give me approximately 1464.96. And this is centimeters cubed. And I'm just going to double check my work. All right. Number 9, we have a water tank that is a composite figure of a cylinder and a sphere. Okay, so this end is half of the sphere, and then this end is half of the sphere. So really just one sphere. And then the cylinder is this piece in the middle, right? Okay, so we want to find the total volume. So we have the volume of the sphere, and let's see, volume of the sphere, that is 4/3 pi r cubed, and we have volume of a cylinder, which is base times height, and our base is a circle, so that's pi r squared times height. All right, and let me see if I can clear up some of these numbers. The diameter, which is really hard to read on my diagram, is going to be 8.4, so my radius is half of that, so that is going to be 4.2. The height of this cylinder, that is 15.2. All right, so let's plug in. So we have the volume of the sphere, so that's 4/3 pi times the radius cubed, plus the area of the cylinder, which is the base, pi times the radius squared, times the height. All right, put this in your calculator, 4/3, and I'll write it first in terms of pi. So this is going to give me 366.91 pi, and this is volume, and these are in millimeters cubed. And if I were to work out the pi, that is approximately 1,152.69 millimeters cubed. All right, one last problem. A cube-shaped piece of playground equipment has a cylindrical portion removed. Okay, so if we're going to remove it, we need to subtract out what this cylinder is. The diameter of the opening is 5 feet. So this diameter here is 5. So diameter. Okay, in all of our formulas, we've always used radius. So I'm going to go ahead and cut that in half, and so my radius is 2.5. So we need to find the volume of a cube. Okay, so volume of a cube is just base times height, and the base in this case is a square, so it's really side squared And the height is also, so it's really side cubed. All right, and then we have volume of a cylinder, and that is also base times height, where my base, though, is a circle, so this is pi r squared. That doesn't look like squared. Okay, so now let's go ahead and find the volume of the cube. So the volume of the cube is going to be 6 cubed, and we're going to subtract off the volume of the cylinder, which is pi times the radius squared, times the height. I almost forgot the height part, and that is 6. That is the length of the cylinder. Okay, so let's go ahead and work this out. 6 cubed, and then minus 2.5. Oops. Okay, so this is going to give me 178.5. Hold on. I think I just did that wrong. Let me double check my math. 6 cubed would be 216 minus 37.5 pi, and this would be feet cubed. Now if I work out the pi, that would give me approximately 98.19 feet cubed.